Okay, imagine we want to determine the acceleration due to gravity at the top of Mount Everest. We can use a 2.75 meter long pendulum to do this. We know the equation for the period of the motion of a pendulum. It depends on its length, which is fixed in this case, 2.75 meters, and it depends on g. The bigger g is, the shorter the period would be. The smaller g is, the longer the period of motion. Now we're on the top of Mount Everest. We're quite a ways away from the center of the Earth, or at least a little bit farther away from the center of the Earth. So g should be a little bit smaller. So we want to solve this equation for g. So when I do that, I can start by dividing both sides by 2 pi. So I get t over 2 pi is root L over g. Now I can square both sides to get rid of that square root. And I get t squared over 2 squared is 4 pi squared. Everything in the brackets gets squared, equals L over g. And then the only thing left to do is to get g out of the denominator. So multiply both sides by g, and then I can finish the equation. So to get g by itself, it equals L times 4 times pi squared, right? All of this goes up to the other side, divided by t squared. Now L is 2.75 times 4 pi squared, and the period is 3.33 seconds, and we have to square that. And when we do all of that, we end up getting an acceleration due to gravity of 9.78 meters per second squared.